Hey everyone, welcome back to my YouTube channel. Myself Aditi Sigowda, presenting in Sri Venkateswara College of Engineering. Subject Applied Chemistry for CSE stream. Topic Corrosion. So let's know about what is corrosion. Corrosion is a natural phenomena which attacks metal by chemical, electrochemical action, converts metal into metallic compound such as an oxide, hydroxide or sulfate. Destructions or deteriorations and consequent loss of solid metallic materials starting at its surface due to chemical or electrochemical attack by their environment. It impacts on safety, health and environmental issues. And it is natural process that converts in a refined metal into a more chemically stable oxide. It is gradually deteriorations of metals, usually a metal by chemical or electrochemical reaction with their environment. So let's know about a causes of corrosion. Pure or noble metals, which are solid silver, platinum, aluminium, copper that do not corrode since they are chemically uncombined in their natural state. That are following conditions must exhibit before corrosion. Presence of metal that will corrode and presence of cathode, presence of conductivity liquid and electrical conductance between anode and cathode. Elimination of any one of these conditions will reduce or stop corrosion. So let's know about a classification of corrosion. On the basis of working temperature, there are two types, low temperature corrosion and high temperature corrosion. And on the basis of working environments, also there are two types, dry or chemical corrosion and wet or electrochemical corrosion. So let's know about dry or chemical corrosion. It occurs when oxygen in air reacts with metal without presence of liquid. It is very sensitive to temperature. Oxide layer on steel and iron is known as rust. As oxide layer formed prevents further contact of oxygen as film is non-porous. Rate of dry corrosion varies from metal to metal as a result of mechanisms involved, and in a aluminium copper oxide layer formed due to reaction with atmospheric oxygen that stops further corrosion. So let's know about a wet or electrochemical corrosion. It is an electrochemical phenomena which occurs in a galvanic cell, particularly when two metals are in contact with liquid. Liquid containing salt and electric potential is formed between the metals. In some cases, in single metal, when comes in a contact with liquid or electrolyte, anode and cathode areas are created. When anode area shorts according with respect to cathode areas, it is termed as wet corrosion. Electrochemical reaction, the transfer of electrons. Electrochemical corrosion cell, that electrical circuit and its associated chemical reaction are called electrochemical corrosion cell. So let's see a small video about corrosion.
Imagine four objects: an aluminium toy, an iron nail, a copper pipe, and a gold ring are left out in the open for many years. Which of the four materials do you think will be in the best condition when they are rediscovered? Pause, think, and continue when ready. If you think the gold ring is likely to be in the best condition, you're right. The copper pipe and the iron nail will appear in a worse condition, but the aluminium toy is also preserved very well. Most likely, the iron nail will appear in the worst condition. This is because of corrosion. Corrosion is described as formation of compounds on the surface of a metal when it is exposed to air and/or water or an electrolyte like salt water. Typically, once a metal corrodes, it forms compounds known as oxides or hydrated oxides. The nail, made of iron, rusted. This, by the way, is the only time you should use the term rusting. All other metals are considered as having been corroded when they react with water and/or oxygen in the air. But why would the nail be more corroded than the aluminium toy, the copper pipe, or the gold ring? Have you any ideas? Pause the video and continue when ready. The reason is the metals all have different reactivities. Iron corrodes faster because it is more reactive than the copper and the gold. But you may be wondering, well, why didn't the aluminium toy corrode the fastest? The truth is, the aluminium is more reactive than the iron, so it reacts fastest with the oxygen from the air, forming aluminium oxide. Aluminium oxide is very unreactive because once the oxide layer is formed on the surface, it binds very tightly to the surface of the metal, so no cracks can form and cause further corrosion. Here's a challenge. How might you use this idea to protect the iron now? The answer is that by covering a metal like iron with another more reactive metal, like zinc, is that the zinc forms the zinc oxide layer quickly. The iron underneath is protected. This process is called galvanizing and can last up to 100 years. If you think of the metal on a bike, corrosion can be prevented by painting the frame, a static part, or greasing the metal parts like the chain which moves, or by covering it with a thin layer of a less reactive metal like tin, copper or gold, but that would be very expensive.
Welcome back. So let's know about a differential metal corrosion. This type of corrosion that occurs due to the difference in the electrode potential of metals on combining two different metals. When the two different metals are in contact with each other, metal which lies high in electrochemical series that act as anode and undergo corrosion, whereas metal which lies in the lower electrochemical series that act as cathode and it is unaffected. So let's know about differential erosion corrosion. Differential erosion corrosion, it is a type of corrosion that occurs when oxygen concentrations vary across a metal surface. The varying concentration of oxygen that creates an anode and a cathode on the metal surface. Oxidation then occurs because an anode and cathode have been established on the surface. So let's know about types of differential erosion corrosion. First, waterline corrosion. Waterline corrosion is a type of oxidation process that can happen to our materials in contact with water. Waterline corrosion occurs when one portion of a base material is submerged in the water and another portion is in contact with air. This creates a differential of the amount of oxygen in contact with the material surface above and below the waterline, and that results in a corrosive reaction. So let's go to the next types of pitting corrosion. It is a deposition of impurities like dust, sand, drop of oil or a water on metal surface that induces a pitting corrosion. Parts of metal covered by the impurities, it is in contact with a less oxygen concentration that compared to other part of metal. Due to this uneven oxygen concentration cell is formed. The part of metal below the impurity which is in contact with a less oxygen concentration that act as anode and undergo protecting the other part of the metal. So factors influencing pitting corrosion is alloying elements, surface finish, heat treatment. Watching my video, please do like, share, comment and also subscribe my video. Thank you.